some of you may want to draw this on the back of your paper. But when we're dealing with these functions, if you just take this cubic that's up there and you look at it and define a few different terms, a relative maximum, you're going to have to sketch this somewhere on your graph, your paper. That's okay. A relative maximum is a part of your graph where there's a maximum point. So if you think of this a hump of the graph or a bump in the graph, that is a relative maximum. Relative minimum is a place where you have a minimum point, where it ends up changing directions and jetting back upward. Okay, now as you study polynomials, you're going to have a lot of different places, a lot of different weird looking graphs. This one's pretty normal looking actually. Okay, there's a relative minimum, relative maximum. These are your x-intercepts or your roots, and this actually happens to also be your y-intercept. It crosses x and y at the same time in the origin. Those roots or x-intercepts we call zeros. Okay, so this is a 0, that's a 0, and that's a 0. We're going to use all of that stuff to help us graph these. Go ahead and try to graph one of these. Let me explain what we do. You guys have your grid. My grids are all separate pages, but the same thing as the first one on your paper. Okay? So taking a look at it. Sketching a graph using its zeros. That's what we're doing here. Now, right now, you'll notice that this whole thing is factored. If I'm using zeros, the zeros for x is when y, or excuse me, the x-intercept is when y is 0. So if we think of that as 0, that means this thing times this thing times this thing equals 0. One of those three is a 0. Okay? So what makes this one 0? What makes this one 0? And what makes this one 0? Okay. So the first thing you need to do is identify your zeros. We have plus, minus 5, and 1. Those are my zeros. The second thing I need to do is identify my degree. What degree is this? If I were to multiply it out, I'd have x times x times x, which would be x cubed. X cubed. X cubed, this is a third degree. Tell your neighbor what the end behavior of the third degree is.
Down up.
Now it's down up as long as it's a positive, right? Now, there aren't any negatives in front of these x's, therefore it's going to be a positive. So it is down up. The next piece is sketching the graph, which is a little tougher. So when we're sketching the graph, we plot our zeros first. Those are points we know. We know it's going to cross the x-axis at -5. It's going to cross at 5 and at 1. Okay? We know our end behavior starts down here. Notice I put it down below the graph. And it ends up here. Now, we also could figure out the y-intercept. Now, I'm not going to expect you to do that tonight unless you want extra credit on this assignment. And you won't always fit it on the grids. Okay, unless you change the scale of your grids. But if you just said, hey, off to the side, if you said, I know my y-intercept is, well, it's what your constants are. -5 times 5 times -1, or it's 25. Your graph will actually cross somewhere up here at 25 if you're going up by ones. Now, we're not going to do that, right? Remember, to find your y-intercepts, it's just you multiply your constants. It's always your constant. Okay, that would just be extra credit. We're not going to put that on the grid. The only thing that's going to be accurate today on your graphs is your end behavior, your zeros, and what happens at those zeros. Your relative maximum and minimums and your y-intercepts are going to be inaccurate. So if you have a math junkie in your house that likes to look over your shoulder every time you do something, and that person's going, you're graphing that wrong, you're graphing it wrong, you go, just say, hey, they want me to just get the zeros and the end behavior correct. They don't care about the relative maximum and minimum right now. Okay? So all that means is my graph starts down here and ends up here, and it has to go through these 3 lines. Show your neighbor how you can make your graph start down here, end up there, and go through those 3 points. Here we go. Here's how I'm doing mine. I'm starting down here. I'm going through that point. I am zipping up. I'm coming back down through that point, and then I'm jumping right back up through there. How many have something that looks like that? That is my graph. Now, it is accurate for in behavior, and it is accurate at the zeros, unless this point actually is, what is it? 25. I mean, if we want to label that and say, yeah, that's 25. You know, I'm going up by 6 1/3 every time. You know, or excuse me, 8 1/3. Okay, that's what each line is. Oh, okay, then that's 25. But you don't have to label that. But that's where it crosses Y. This maximum is not accurate. This is not accurate. In fact, where this goes down is not accurate. That's accurate. That's accurate. That's accurate. In behavior is accurate. That's it. Good? Any questions? It's that simple. That's one problem. Moving on. What's the title of the next one say?
Multiple zeros.
Multiple zeros. Go ahead and find the zeros when you set this equal to 0. Tell me what each of these equal. Actually, tell your neighbor what each of those equal. All right, what makes this quantity 0? Now don't get confused. X plus 2 quantity squared means x plus 2 times x plus 2. What makes this one 0? Negative 2. And what makes this one 0? Negative 2. So what makes this thing 0? Negative 2. Just negative 2. Right? For those of you who are like, what about the squared? What if well, if you set it equal to 0, so if you're like using the math, you're like, well, I just set that equal to 0, and I solved, and I'm getting something else. Well, you're not. You're square rooting it first, right? Square root of 0 is 0, so you get x plus 2 equals 0. And that means x equals negative 2. You guys with me? Okay, so really, no matter what power you have there, it's still that. But that negative 2 actually appears how many times? Twice. This is multiplicity. It's called multiplicity. There are multiple zeros. This appears twice. You could either write a little 2 above it, you could write a little 2 below it if you want, or you could just list negative 2 twice if you want. But it appears twice. And that's a key piece. We'll see that here in a minute. You'll see on my keys sometimes just write the number of times it appears, because if 9 appears 7 times, I don't want to write 9 7 times. I'll just write a 7 by it. Make sure you don't write it in the power position so it looks like 9 to the 7. Okay, this is 1. So my zeros are negative 2, and 1. Any questions with that? Tell your neighbor the degree. Good. So it's 2 second degree plus 1 is third degree. You add the powers. Third degree in behavior then is down up. Sketch the graph. Well, zeros are easy. Negative 2. There it appeared once. And look, there it's twice. Okay, you just put a dot on negative 2. And 1. And in behavior, down, up. Tell your neighbor how you're going to make that graph work. Time's up. Parker, what do you got?
I put the relative maximum as negative 2.
Ooh, I like the vocab.
Curving back down.
Very good. Yeah, you put the relative maximum at negative 2. I like the vocab there. So it curves back down and then it jumps right back up. How many did something like that?
Yeah. I actually did with the relative minimum.
Oh. So you did it at the relative minimum. Good. So, can I borrow yours?
Yeah.
Okay, now Lee did it this way. Did anyone do it that way? It still works, right? Now let me tell you that, you guys, I'm asking you to guess what's happening. Okay? This one is actually correct. This one is not. What tells me that I don't change directions here, but I change directions here? Now, there's something we have different over here that tells me this changes directions on this graph. It doesn't change directions at 1. It changes directions at -2. Cool? Thank you.
The squared is on -2, not on 1.
Good. You have multiplicity of -2. Anytime you have a multiplicity, something happens at that point. In this case, because it's an even multiplicity, you change directions. Okay, which implies when it's an odd multiplicity, something else happens. Okay, it's even because there are 2 of them. It's not because the number is -2. It's because it happens twice. There are 2 -2s. That's an even number. There are 2 of them. So it changes directions. And we call that a bump. Okay, when you have an even multiplicity, your graph bumps. It goes up and bumps back down. It's like hitting a wall and jumping back down. Everyone get that? Okay, make sure you make a note of it. Questions there? What's the y-intercept on this one, by the way? 2 times 2 times -1 is?
-4.
Y-intercept equals -4. Okay, so this would 1, 2, 3. Well, okay, so we'll put that at -4, and we're saying we're going, yikes, we're going up by 4/3 every time. All right, or down by 4/3. All right, you don't have to have the y-intercept. It's just an added bonus. All right, moving on. Next graph. Tell your neighbor the zeros. All right, if this is 0, oops, make that 0. That means if this part's 0, what's our answer? X squared equals 0 gives me 0. How many times? Twice, right? That squared means there are 2 of them. That means really this, if we expand all this out, it means we have x times x plus 3 times x plus 3 times x plus 3. All equals y, or 0. Which means this part could be 0. That's 1, 0. This part could be 0. This part could be 0. What makes that 0? -3, -3, -3. So the shortcut is just to look at the power. There are 2 of those, and there are 3 -3s. Those are my zeros. Your degree, add your powers, is 5th. It's an odd degree, in behavior is down, up. Sketching our graph. Down, up. Little disco dancing arrows there, man. Okay? We have 0, and we have -3. We have an even multiplicity. We know at 0, it appears twice. That's an even multiplicity. So you could write this as 0 appears twice and -3 appears 3 times. That's McCoy-Vogel notation. Okay? If you want to do that. All right? We know when there's an even multiplicity, it's going to be a bump. For those of you like a bump, I got to remember what that means. Remember, that means it changes directions. Either like that or like that. It's a bump. An odd multiplicity, I will tell you, is a slide. You still have something happening, and be careful with your slides. I have some, usually my 9th graders are very messy sliders. Your slide should look like, if you have a point, it should look like a parabola starting downward, and on the other side, a parabola going upward. I should see a slide at that point. Or a parabola going downward like that. Okay? So once again, there are 2 zeros because of the x squared. X times x plus 3 times x plus 3 times x plus 3. 2 zeros. There are 3 -3s. The shortcut is to look at the power. Okay? There are 3 of those. That makes -3. You get 3 of them. It's a 5th degree by adding your powers, which means it's down up. We know that an even multiplicity is a bump. So at the point you bump, either that way or that way. The odd is a slide. So remember, it's like a half parabola going down and then up. You've got to look, make sure it slides. So when I plot them at -3 and 0, I start down here, I go to -3, and since there's an odd number of those, there's 3 of them, we slide. We change directions and go down to 0, and since there's an even number of those, we bump and go back up. Y-intercept is 0 because 0 times 0 times -3 times -3 times -3 is 0. Yes?
How do you know, like the one up above, like how do you know, like which one to do the bump, like over or under?
Well, it just depends. Like in this one, we had to do it right like this because we're coming down on it. And we have to end up back up here. So your graph will kind of tell you how to do it based upon your end behavior. Okay, let's try another one. Any other questions on that? It'll be a little more clear as we go through. So go ahead and turn your paper over. On the other side, go ahead and tell your neighbor your zeros, please. Zeros.
1 negative 1.
Should be getting hopefully good at these now. Okay, fill out as much as you can on that. Okay, this is 1. How many times does 1 appear? Twice, because of the squared. So 1 appears twice. This is -1. How many times does it appear? Twice. Okay. Degree is 4, which means my graph is up, up. Okay, so I guess I should put that with the end behavior. Up, up. Okay, we sketch the graph. We go to 1 and -1. I know I need to begin up here, end up here. Okay, if I'm going to do that, am I bumping or sliding right here? Bumping, and here? Bumping. So I know, so Lily, your question, like how do you know? Well, I know I'm going to be coming down to this point, so no, I'm going to be bumping like that. And then I'm going to have to change directions and get back to this point, so this one's actually going to be a bump as well, right there. Okay, so really if you wanted to figure out your y-intercept in this case, -1 squared is 1 times 1 times 1. Y-intercept is 1. So really, like if you, let's say we go up by a half and call this 1, so that we're not cramming ourselves. We're going up to here, we're changing directions. It's a W looking piece. Coolio? Everyone rate themselves 1 to 5 right now. All right, very good. Hey, I'm going to be done. You guys can practice the other 2 if you want. They were just there for the fun of it. I do want to talk to you about how to do these in standard form, and we need to spend time multiplying one of these out. So somewhere on your page, maybe off to the side of those last 2 graphs or something, I need you to multiply this out. Multiply that out. Put it in standard form. Those of you, by the way, that are hard times getting started, remember x plus 2 quantity squared means x plus 2 times x plus 2. And then you have that other x plus or x minus 1 there that we bring down. Okay, so my suggestion to you when you're multiplying these out, until you learn the binomial theorem, which makes them a little quicker, but my suggestion to you is doing this. Just multiply 2 at a time. So x squared plus 2x, and then 2x and 4. So I'm just multiplying 2 binomials at a time. I'm ignoring the back one for a minute. Okay, it gives me x squared plus 4x plus 4. How many can do that one in your head? Very good. If you can do it in your head, great. Okay, if you can't, multiply it out. And then you have this times x minus 1. You got to do it again. All right? Now some of you are pretty good with this. Some of you really would rather see it like this, where you change, you say, well, that's really, excuse me, not x, it's, or y, it's x minus 1 times x squared plus 4x plus 4. You can switch those, right? You can multiply in any order, and then you go that times that, that's x cubed. That times that, that's 4x squared. That times that is 4x. That times that is negative x squared, so I'm going to put it under the x squared. That is negative 4x and negative 4. It's x cubed plus 3x squared plus 0x, so we'll put nothing there, minus 4. That is standard form. Quite a bit, right?
Wait. Oh, yeah.
Now, here's the deal. Some of you learned using the area models or box method to do that. How many of you have done that? For those of you who struggle doing what I just did on this one, then I find the area model fairly helpful. I would write the x squared here, 4x there, and 4 there, each term. And then on the side, x and negative 1. It's just a 2 by 3 box. That is x cubed, x times x squared. That's 4x squared. That's 4x. That's negative x squared. That's negative 4x. And that's negative 4. No other x cubes. There's my x squareds. That makes 0 minus 4. Okay, same thing. It's using the area model. Okay. How many got it? Okay, questions? Parker, question?
Oh, no, I was just...
Stretching out. Okay, last one. Here it is. Number 1. Write a polynomial function in standard form given the zeros. So tell your neighbor, if I know that one of my zeros is 1, if I'm writing this out, what binomial would that be? Okay, volunteer? Yeah? Go ahead.
Negative 1.
Yeah, it'd be x minus 1, right? Because x minus 1 makes 1. Okay, what makes 2? X minus 2. What makes 3? X minus 3. You now have 3 that you have to multiply out to get in standard form. Okay? So many of you are good at multiplying 2. You look at that and you go, I know that's x squared. That's the front. The back is negative 3, or positive 2. And negative 1x and negative 2x is negative 3x. 2 of them should be easy. It's when you have to multiply a trinomial by a binomial that gets a little more complex. Okay? So x cubed, you can go backwards. Negative 3x squared plus 2x. And then you go here. Negative 3x squared. Positive 9x and negative 6. X cubed minus 6x squared plus 11x minus 6.